Welcome back, everybody. We're up to lesson 12 now, and in this lesson, we're going to do something that you've probably never done before. We're going to learn how to divide polynomials. And the way we're going to divide polynomials, we're actually going to use the box method, okay? We're going to use the box method, the same box method that we use to multiply polynomials, but we're going to do them in reverse. And the way we're going to do that is by thinking of division as reverse multiplication. We're going to think of division as reverse multiplication. Now, what do I mean by that? Well, let's think of a division problem that we already know the answer to. So, for example, let's say 12 divided by 2. We, of course, know that 12 divided by 2 is equal to 6. And the reason that that is true is because 6 times 2 is equal to 12, okay? When I'm doing 12 divided by 2, what I can really ask myself is 2 times what number is equal to 12? And of course, we know that 2 times 6 is 12. If we do another one, how about 20 divided by 5? Okay, we know that 20 divided by 5 is, of course, 4. The reason that is true, again, is because 5 times 4 is equal to 20. When we're doing 20 divided by 5, we can really ask ourselves is what do I need to multiply 5 by to get 20? In other words, 5 times what equals 20? And the answer, of course, is 4. 5 times 4 is 20. Let's do one more before we move on. How about 15 divided by 3? Okay, so we know how to do 15 divided by 3, but the different way we can think of it is if I look at the denominator again, the denominator is 3, so I can ask myself 3 times what number is going to give me 15? What do I need to multiply 3 by to get 15? Of course, we know that that answer is 5. We know that 15 divided by 3 is 5, but we can think of it in terms of multiplication. So that is what I mean when I say we're going to think of dividing polynomials as reverse multiplication. And that is why we're going to use the box method in reverse in order to divide polynomials. So how is that going to work? Let's go back and look at the lesson notes. Okay, this is how we're going to set it up. So when we're dividing two polynomials, we're going to put the denominator along the side of the box. We're going to leave the top of the box blank because we're going to figure out what do I need to multiply the side by in order to get the numerator as an answer. So the numerator is the answer when multiplying, and we need to account for missing exponents with zeros. And we're going to go column by column. So the top left is going to be the first term of the numerator. And then we're going to work from the leftmost column to the rightmost column. The diagonals should add to the next terms. And when I say next terms, I mean next terms of the numerator. And the key is we're going to repeat this until we get to our constant term. So we're going to repeat this until we get to our constant term. So let's look at our examples here. Here are some polynomial functions with known factors. Rewrite each polynomial as a product of linear factors. Note you may not need to use all the columns in each diagram. For some problems, you may need to make another diagram. So when I have a polynomial and I have at least one of its factors, I can figure out its other factor by dividing. Okay, so for example, in this one here, my polynomial here is x cubed minus 7x squared minus 16x plus 112. That's my polynomial, and this right here is one of my factors. So the way I'm going to figure out what my other factor is by dividing the polynomial by the factor. So this is going to be my numerator, and then x minus 7 is going to be my denominator. So what I'm doing is x cubed minus 7x squared minus 16x plus 112 divided by x minus 7. And you can see we already did part of the setup here. If we go back to the lesson notes, again, the denominator goes along the side of the box. Denominator goes along the side of the box. We would leave this blank, okay? And then we would put the first term of the numerator in the top left here. And the way we're going to do this is as follows. So if we make believe that this x squared isn't here, we need to ask ourselves, x times what is x cubed? Well, of course, I know that x times x squared is x cubed. So I figure out that x squared has to go on top of this column because that's what I need to multiply x by to get x cubed. Once I figure out what goes on top of the column, I can finish out that column. So x times x squared is x cubed. Negative 7 times x squared is negative 7x squared. Okay, so that's the first column. Okay, if you remember when we're doing normal multiplication with the box method, remember the diagonals give us our like terms. So if I look at my next term of the numerator is negative 7x squared. So the question would be, what do I need to add to negative 7x squared to get negative 7x squared? And of course, in this case, I need to add 0. I need to add 0. Technically, I'm adding 0x squared. Okay, technically, I'm adding 0x squared. Okay. So now we're going to repeat this process again. So I have 0x squared here. So to figure out what goes on top of the second column, I'm going to ask myself, what do I need to multiply x by to get 0x squared? And of course, that's going to be 0, right? X times 0x is going to be 0x squared. All right, and then I can finish out the columns. So negative 7 times 0x is going to be 0x. Okay. Notice I'm not down to a constant term yet, so I have to keep on going. So if I look at the next term is negative 16x. So the question is, what needs to go here? What do I need to add to 0 to get to negative 16x? And of course, I need to add a negative 16x, right? 0 and negative 16x becomes negative 16x. So that goes up here. And now I'm going to do the same thing again. So now to do the third column, I need to figure out what x times what is negative 16x. So x times what is negative 16x. And that's going to be negative 16, right? Is x times negative 16 equal to negative 16x? Yes, of course it is. So now I can finish out the column. So negative 16, this is going to be negative 16 times negative 7. So I'm going to use a calculator here. So negative 16 times negative 7 is a positive 112. And you now can see I got down to my constant term, which means I'm done. Okay, so I will not lead these next two columns. So what is the answer? If I divide this by this, the answer is, so x cubed minus 7x squared minus 16x plus 112 divided by x minus 7. If I divide that, my answer is going to be x squared plus 0x minus 16. That's the answer. So right now, my two factors are x minus 7 and x squared plus 0x minus 16. Now notice here, it says to rewrite each polynomial as a product of linear factors. Okay? This factor is linear. This factor is quadratic, which means I need to factor this now. So I can factor this by doing that add multiply thing. Okay? So the question I can ask myself is, what are two numbers that when I add them I get 0, and when I multiply them I get negative 16? So two numbers that add up to 0 and multiply to negative 16, that's going to be 4 and negative 4, right? Because 4 plus negative 4 is 0, and 4 times negative 4 is negative 16. So my two factors for that are going to be x plus 4 and x minus 4. And if I combine that with the first factor of x minus 7, I now have taken the polynomial and rewritten it as a product of linear factors. And I used division and I used factoring to help me to do that. So I used division and I used factoring to help me to do that. So let's look at number 2 now. So now I'm going to divide 2x cubed minus x squared minus 27x plus 36. I'm going to divide that by x minus 3 halves. Okay, so you can see they already did the first column for us. So x times 2x squared is 2x cubed. Negative 3 halves times 2x squared is going to be negative 3x squared. Now, where did this 2x squared come from? Well, if I look at the next term and ask myself, what do I need to add to negative 3 to get to negative 1x squared? Of course, I need to add positive 2. Negative 3 plus 2x squared is equal to negative 1x squared. So that's where that comes from. So this next column, x times what is 2x squared? X times what is 2x squared? And that's going to be 2x, right? X times 2x is 2x squared, all right? Negative 3 halves times 2x. Negative 3 halves times 2x is going to be a negative 3x, okay? I have to do at least one more column because I don't have a constant term yet, because remember, I have to repeat the process until I get down to the constant term. So to figure out here, I'm going to look at the next term, which was negative 27x. So what do I need to add to negative 3 to get to negative 27? In other words, negative 3 plus what is negative 27x? And that's going to be a negative 24x. Because if I combine those, I get negative 27x. Okay. Third column, x times what is negative 24x? That's going to be a negative 24, right? X times negative 24 is a negative 24x. And then if we multiply that out, negative 24 times negative 3 halves is going to be positive 36. And again, because I'm down to a constant term, I'm done, which means I don't need these last two columns. So the answer, 2x cubed minus 1x squared minus 27x plus 36, the answer of that divided by x minus 3 halves, the answer is 2x squared plus 2x minus 24. Okay, so right now, just like before, my two factors are going to be x minus 7 and then 2x squared plus 2x minus 24. Okay. Now this one is interesting because this one, because all of the terms are even, I can actually factor out a 2. So watch what I do here. I can take out a 2. If I take out a 2, this becomes x squared plus x minus 12, right? If I take out the 2, that means I have to divide everything in here by 2. And I end up with x minus 7 times 2 times x squared plus x minus 12. This is still not a linear factor, which means I need to do factoring again. I need to do my add multiply thing. So what adds up to positive 1 and multiplies to negative 12? So two numbers that add up to positive 1 and multiply to negative 12. That's going to be 4 and negative 3, right? Because 4 plus negative 3 is 1, and 4 times negative 3 is negative 12. So that, the x squared plus x minus 12, that's going to break down into x plus 4 and x minus 3. If I put everything together, I'm going to actually have 4 factors total. I'm going to have x minus 7 times 2 times x plus 4 times x minus 3. And that is your answer to number 2. Number 3, all right, same thing. We have x cubed minus 3x squared minus 13x plus 15, and we're going to divide that by x plus 3. So we're going to start off by putting x cubed here, right, since that's my first term. So I'm going to ask myself, x times what is x cubed? So that's going to be x times x squared. X times x squared is x cubed. I can finish out the column. 3 times x squared is going to be 3x squared. Okay. So when I go to this diagonal here and I look at my next term, I need to ask myself, what do I need to add to 3? So 3 plus what equals negative 3x squared? So I need to add a negative 6, right? Is 3 plus negative 6 equal to negative 3x squared? And the answer is, of course, yes. So this is going to be a negative 6x squared. Let's do this second column now. So x times what is negative 6x squared? That's going to be a negative 6x. Finish out the column. X times negative 6x is negative 6x squared. 3 times negative 6x. 3 times negative 6x is going to be a negative 18x. All right, I still have to do at least one more column because I haven't gotten to a constant term yet. So my next term here is negative 13x. So negative 13x. So what needs to go here so that I have negative 18 plus what is negative 13? And that's going to be a positive 5x, right? Because negative 18 plus 5 is negative 13x. So now I can do the third column. So x times what is 5x? That's going to be x times 5. X times 5 is 5x. 3 times 5 is 15. I'm down to my constant terms, so I'm done. So my answer for x cubed minus 3x squared minus 13x plus 15 divided by x plus 3, that answer is x squared minus 6x plus 5. So my two factors are x minus 7, okay, and then x squared minus 6x plus 5. This is not a linear term, the second one here, so I got to do the same thing I've been doing. So what adds up? So what adds up to negative 6 and multiplies to positive 5? So what adds up to negative 6 and multiplies to positive 5? That's going to be negative 5 and negative 1. Negative 5 plus negative 1 is negative 6. Negative 5 times negative 1 is positive 5. So that's going to break down into x minus 5, x minus 1. And my third factor, combine that with, is that. So my three factors are x minus 7, x minus 5, and x minus 1. So that's number 3.